Hi folks, so welcome to Pythagoras Theorem in 3 dimensions. This is the first part. Okay, so most real life scenarios involve 3D shapes, and more often than not, those shapes have straight lines that form the right angle triangle somewhere. Okay, now therefore, Pythagoras' theorem can be used to solve problems in 3 dimensions. Now, the most common examples are boxes and pyramids. Now, when working with 3D shapes, it is very important to draw out the shape so you can visualize it. Without being able to visualize 3D shapes, folks, it is super difficult to apply any kind of logic to them, okay? Especially when it comes to Pythagoras' theorem. All right, so let's have a look at this simple example for now. So we have a rectangular prism here, okay? What we are basically doing is, if you notice, the very bottom left-hand corner, which I've designated A, and the very top right-hand corner, which I've designated D, if you draw an imaginary line between them, if you can visualize that, so the bottom left-hand corner here and the top right-hand corner up there, if you draw a line there, that does in fact form a straight line, obviously. But if I was to draw another line connecting the bottom left-hand corner with the with the bottom right-hand corner, if you notice that in fact does give us a right angled triangle. So let me draw the straight line here. Okay, there you go. So the blue, the pink, and the red does in fact form a right angled triangle. Now, if I was to, let's say, give this side the name C, and if I was to draw this out in 2D, right, you keep using the red, so that would be my A, okay? This top part will be my D, and then this part will be C. So A, C, and D. There you go. Okay, so we're going to use this kind of logic to solve the next few questions. Okay, so let's get into it. All right, so this question says, calculate the length of BH. Okay, so let's see what BH actually is. So let me use the color pink, so it stands out. Okay, so there's B up there. Okay, there's B in the corner, top right-hand corner, and there's H in the bottom left-hand corner here. So if I was to draw a line between them, so joining H, now folks, this is not going to be super accurate, but you just have to do the best you can when it comes to 3D shapes. And remember, they don't really have to be to scale in order for you to be able to answer this question. Okay, so I've joined the H here and the B on the top there. Okay, now let me join the H and the F as well. So, okay, so we have the H. There you go. So there's the F right there, and there's a H right there. And B and F are already joined by that line there, which is given to us as 14. Okay, so let's draw this out. So if I was to draw this out, there's my right angle triangle right there. Okay, so that part is H, that part is B, and this part is F. Now, folks, I want you, when you're answering questions like these, I want you to follow the exact steps that we're going through here. Okay, if you follow these steps, very small chance that you're going to get it wrong. Okay, so B, H, and F forming the right angle triangle there. Now, BF has already been given to us as 14. HF we do not know. Okay, and BH is what we need to find, which is obviously something that we do not know as either. However, if you notice, now H and F at the bottom have been joined, right? But that is actually the diagonal of the triangle that's formed by HG, FG, and then HF. So if I was to draw this out in 2D, so we can visualize this a little bit better, okay? So that's a bit too much there. Okay, so we have F at the top there, okay? We have G at the bottom here, and then we have H in the corner here. All right, now FG has already been given to us as 14. HG, same thing, it's 14 as well. Now FH is what we need to figure out. Now FH, and I'm going to use a different color so it stands out, is this line right there, which is the diagonal. So if I was to translate that to my 2D shape, it's this bit here. Okay, so that red line right there is my FH, which is what I can use to determine this line here. So see that red line there? That is the exact same line that is that is the hypotenuse of the other triangle. Okay, so let's work this out. So let's say that is A, that is B, and that can be C. Okay, so we have 14 squared plus 14 squared is equal to c squared. 14 squared gives me 196, plus 14 squared is simply times 2, which is equal to c squared. 196 times 2 is simply 392, equals c squared. So c is equal to square root of 392, which gives me approximately 19.8. Fantastic. So now we have a value for fh, which is 19.8. And that can be 19.8 as well. Whoops, let me try that again. 19.8. So we have 14, we have 19.8, and to figure this part out, again, it's a simple Pythagoras theorem, right? So we have, let's go again, so we have 14 squared plus 19.8 squared is equal to BH, and let's designate BH as C again, so C squared. So 14 squared plus 19.8 squared gives me 588.04, which is equal to C squared. Then taking the squared to the other side, we have C is equal to the square root of 588.04, which gives me 24.2, okay, approximately. Just rounding it off now. So 24.2 is the distance, or the length of BH is equal to 24.2. So that's it, folks. So that's how we do, that's how we use Pythagoras' theorem in three-dimensional shapes. So now let's go ahead and do a few more examples. So once again, we have a rectangular prism, and we are asked to find the length between that point there, which is B, and that point there, which is H. Okay? So if I was to draw a straight line between them, there we have it, as straight as n can be at least. Once again, step number 2 is to draw them out in a, actually, let me join these points up as well. So we have HF, and we have BF, okay? So that forms a right angle triangle, as we can see. So let's draw it up here. I'm going to keep using my pink. Okay, so we have H at the bottom there. We have, sorry, not G. We have F right there. And we have B up here. BF has been given to us as 7. HF we do not know yet, but we do know that it forms the hypotenuse of this triangle at the bottom here. So HG, GF, and then HF. So let's draw this one out as well. So we have H in the corner here, we have G right there, and then we have F up here. So the hypotenuse, so the FH here is the same as the FH here. So HG has been given to us as 4, FG has been given to us as 6, as we can see down here. Okay, so now let's designate some values. So we have, that can be A, that can be B, and that can be C. So we have 4 squared plus 6 squared is equal to C squared. 4 squared plus 6 squared, that gives me a value of 50, okay, which is equal to C squared. Sorry, not 50, 52, apologies. Then C is equal to the square root of 52, which gives me 7.2. Okay, so that value right there is 7.2. So that bit right there is 7.2. Excellent. So now we have 7.2 down here. So we need to find the C for this one. So we have 7.2 squared. I'm not sure why I wrote it like that. 7.2 squared plus 7 squared is equal to C squared. 7.2 squared plus 7 squared gives me 100.84, which is equal to C squared. And C gives me a value of 10.04. Fantastic. So the value for C in this case, which is BH, is equal to, I can even write it down here. So BH is equal to 10.04. Fantastic. It's a fairly straightforward method, as you can see. All right, so now let's have a go at the next set of questions. Okay, so this question says, again, calculate the length, AG this time. So not BH, which is what we just did. Let's do AG. But you'll see that it is exactly the same thing. So we have A as the top left-hand corner there, and G as the bottom right-hand corner here. Now let's just quickly join them together. So we have A joining with G. There you go. Then we have AE, and then we have EG as well. So if we were to draw this out, we have that triangle right there. So we have A sitting at the top, we have E sitting at the bottom, and then we have G sitting at the top bottom right hand right there. Okay, AE has been given to us as 10.3, because as you can imagine, 10.3 is BF, so this has to be also 10.3. Okay, then EG we do not know yet, and AG is obviously what we need to find. However, as you would have already noticed, EH, HG, and then EG actually form a right angled triangle as well. So let's draw that out. Okay, so we have HG at the bottom there, and then we have E sitting at the top there. So the hypotenuse, which is EG, is one of the sides for the triangle that we need to solve. Okay, so EH has been given to us as 7.9, as we can see. So if FG is 7.9, then EH has to be 7.9 as well. Okay, then HG is 6.2, as you can see from the diagram here. So let's designate that A, give that B, and that can be C. So we have 7.9 squared plus 6.2 squared is equal to C squared. Okay, 7.9 squared plus 6.2 squared gives us 100.85, which is equal to C squared. And then C is equal to the square root of 100.85, which is 10.04. Cool. So C is 10.04. That means EG down here is 10.04 as well. So the next, let me use a different color so it stands out. So the next bit of calculations we need to do is the Pythagoras Theorem for this particular triangle now. So we have 10.3 squared plus 10.04 squared is equal to C squared. 10.3 squared plus 10.04 squared gives us 206.9 is equal to C squared. So C is the square root of 206.9, which gives us 14.4, which is the same thing as AG. So AG is equal to 14.4. Excellent. Now, folks, we've gone through 3 of these examples now. So what I want you to do, you may have already guessed, is I want you to pause the video and have a go at part B here on your own, and we'll come back to it in a couple of seconds. Alright, so again, we have to calculate the length of AG. So A is this corner here, G is this corner here. So let's join them through. Then, as we can imagine, this forms a triangle right there. So let's draw it out. We have this triangle here. We have the A sitting at the top right there. We have the E sitting at the bottom right here. And then we have the G right there. AE has been given to us as 2.3. EG, we do not know yet, but we do know that it is in fact the hypotenuse of the triangle sitting at the bottom there, which is given by EH, HE, and then EG. Okay, so let's draw this out. So we have E at the top right there. Then we have H at the bottom here. And then we have G. Okay, EH is given to us as 4.9. HE is given to us as 10.3. And EG is given to us, well, we don't know what it is yet. So let's designate some letters and find out. So let's call it A, let's call it B, and that can be C. So we have 4.9 squared plus 10.3 squared is equal to C squared. 4.9 squared plus 10.3 squared gives me 130.1 is equal to C squared. Taking the square to the other side, we have C is equal to the square root of 130.1, which gives us 11.4 approximately. Okay, so that is 11.4. So that is 11.4. Okay, so again, we call it A, call it B, and call it C. So 2.3 squared plus 11.4 squared is equal to C squared. 2.3 squared plus 11.4 squared gives me 132.2, let's call it 3.3 is equal to c squared. So c is 11.5. So AG in this particular case is 11.5. There we have it. So folks, that brings us to the end of the first part of the Pythagoras theorem in 3 dimensions. Okay, we're going to continue to have a go through some more prison type scenarios and finding the corners using Pythagoras theorem. So I hope this was helpful. Make sure you have a go through the worksheets and go through the lecture a couple of times if you need to really get your head around how we actually do the calculations. And you would have seen in all the 4 examples, I followed the basic same steps each time in order to solve them. So thanks again, and I will see you in the second part.